Hi, we're from Group F. Today we'll be discussing about internal combustion engine cycle. So this is our group member consists of Muhammad Zaid bin Abdul Jabbar, Muhammad Aiman bin Malik, Muhammad Razak Adadi bin Abdul Halim, Nur Izzah Atirah bin Zinuddin, Aloysius Havin Rao, Alat Laki Jagendra. So the table of content for our presentation is introduction and basic principle of the system, schematic drawing and explanation, method of performance analysis, performance calculation of the system, and suggestion of system improvement. Moving on to introduction and basic principle. So what is internal combustion engine? Internal combustion engine is a type of heat engine that transforms chemical energy to mechanical energy. The combustion of fuels with oxidizer will occur and it was part of the working flow circuit. So ICE is the most common power source for transportation. This is the one of the ICE engine. So the type of internal combustion engine consists of three engines, which is petrol engine, Carnot engine, and diesel engine. So we will be discussing about diesel engine. So diesel engine, this is the picture of the diesel engine. It used compression ignition instead of spark ignition that used in gasoline. And it only compressed air, and it was high efficiency and durable. And it's preferred because of its fuel efficiency and used in high torque application. So where does diesel was used? It was basically used in heavy machinery and heavy transport, such as truck. The use of diesel made it easy to carry people and things. Moving on.
The schematic drawing and explanation. In our experimental setup, we start with the weight indicator. The weight indicator is used to measure fuel. Then fuel goes into the tank. The fuel is stored here temporarily before the combustion. Next, fuel passing through the air filter to ensure only clean air is used for the combustion. The gas meter measures fuel volume used by the engine. Next is the diesel engine where fuel is combusted and power is generated. Then the exhaust gas is released to the environment. The gearbox is used to transfer power to the other component. Next, the carding transmission distributes power to the other parts. A compressor provides air pressure stored in the receiver. A thermometer monitors temperature and a manometer tracks pressure. Valves control air flow and fuel flow. The air is released to the environment. Together, these components help researchers study diesel engine performance and environmental impact accurately.
Moving on to the method of performance analysis. Figure 1 shows the speed characteristics of diesel D21A1 while functioning on fusel oil for the dotted line and diesel for the solid line. So in the terms of change of torque and power, we can clearly see that diesel has a higher gradient than the fusel oil, while sentinel expense of fuel and changes of specific expense of fuel. Fusel oil has a higher gradient than diesel. This clearly shows that diesel is much more efficient than fusel oil. Moving on to the next graph, it talks about the dependence of cetane number CET of mixture of diesel fuels with fusel oils by volume maintenance of fusel oil, or known as VFO. So the cetane number increases with the maintenance of fusel oil, which is stated in the graph. So increase in combustion fuel maximum pressure increases three things, that are fuel cost, toxic smoke, and exhaust gases. However, the optimal proportion for fuel is around 4 to 10%. But advance in diesel engine increases compression for higher cetane number. For example, high force passenger cars, for example, lorry, van, the proportion of fuel can be 12%. So next, it is the representation of changing of time expense of fuel and oxide of carbon in exhaust gases of engine. So there are two curves. So the first curve, as the fusel oil volume increases, the proportion of the oxide of carbon in exhaust gases also increases. While for the second curve, as the sentinel expense of fuel increases, the proportion of the oxide of the carbon in exhaust gases also increases. This figure 3, relates back to the figure 1. Lastly, is the dependence of change of hydrocarbons and oxide of nitrogen in exhaust gases of the engine. So there are still two curves. Two curves. The first curve, as the fusel oil volume increases, the proportion of the hydrocarbon in exhaust gases of an engine also increases. And the maintenance of the oxide of nitrogen in exhaust gases also increases when the fusel volume increases. Not forgetting the disadvantage of diesel gases. Diesel gases contains harmful components such as nitrogen oxide, sulfur oxide, and soot, which is known as a non-toxic substance that absorb hydrocarbon. This is why you can see that most of the diesel engine powered car tend to release black smoke. So that's all
So
from me.
great speech, Hala. So we will continue with the performance calculation of the system. So in here we can see the several step and consideration on parameter for a diesel engine's combustion process. We can see there are four several steps, which is the air flow ratio AFR. Second is combustion pressure and temperature. The third one is indicated mean effective pressure IMAP, and the last one is power output. So, in the air-fuel ratio AFR is critical for understanding the combustion process. We can see here the formula is mass of air over mass of fuel, so we can get the FR. And then the second one is combustion pressure and temperature. Using the ideal gas law and the first law of thermodynamics that we have learned, which is PV equal to nRT. P is the pressure, V is the volume, N is number of mole, RD is the universal gas constant, and the T is temperature. We can get the combustion pressure just by substitute into the formula lah. Then we will continue with the adiabatic compression, which is T2 equal T1, Cr power of gamma minus 1, and the P2 equal to P1, Cr power of gamma. T1 and P1 are initial temperature and pressure. T2 and P2 are temperature and pressure after compression. The gamma is the specific heat ratio, which is equally to 1.4 for air. Then we continue for the indicated mean effective pressure IMAP. IMAP is a measure of the engine's efficiency and the performance. We can see here there are VD, which is displacement volume, and the P theta is for the instantaneous cylinder pressure, and the P min is the mean effective pressure over the cycle. And the last one, we have the power output. The power output can be calculated from the IMAP. We got P equal to IMAP, V, D, and over N, and over 2.6. And the P is the power in watts, the VD is the displacement of volume, and N is the engine speed in RPM. So we can see here the example calculation. So we can see below we have already have the information, which is the displacement volume 2 liter, compression ratio 18:1, initial condition T1 300 Kelvin and P1 1 bar, and the engine speed is 3000 RPM, and the P min is 10 bar. So from the first we can get the compression temperature and pressure. We just substitute into the formula, which is we can get 948 Kelvin for the T2, and the P2 we can get 43.5 bar, and from there we can get the power output. From the power output we already have the IMAP, which is 10 bar, and then we just substitute into the formula, and then we can get the 500 kilovolt. So that's all from me.
Thank you, Zai. Next, suggestion of a system improvement. Suggestion of improvement for internal combustion engine. First, variable valve timing. Previously, the volume of fuel or air that entered the combustion engine could not be adjusted. However, with the introduction of variable valve timing technology, it is now simple to adjust the amount of air and fuel that entered the combustion engine. The fluctuation of air and fuel occur via an ideal timing valve, which ensures that inject fuel produce maximum power. Smaller engine can generate more power. This is variable valve timing. Next, turbocharger. The primary technology governing the operation of the turbocharger is an increase in air compression into the cylinder, resulting in increased power from the fuel utilized. In design, fuel conversion improves as thus engine and fuel are used more efficiently. However, proponents of this technology claim that it increases ICE efficiency by allowing for smaller engine and more power. As a result, turbocharging technology generally improves the efficiency of ICE. This is turbocharger. Next, suggestion of improvement for diesel engine. Diesel oxidation catalyst. Diesel oxidation catalyst promote the oxidation of exhaust gas component by oxygen controlling carbon monoxide, HC, and other emission. It support the performance of diesel particulate filter and SCR catalyst for NO reduction. Catalytic neutralization interest for car meeting Euro 5 ecological standard reduce harmful component by nearly 88%, making it essential for proper cleaning of diesel engine. This is diesel oxidation catalyst. Second, Camera direct injection. Camera is a fuel injection system used in modern diesel engine, offering flexibility for emission control, power, and fuel consumption. It allows original equipment manufacturer to design for optimal performance and end-user value across various mission and application. Camera direct injection fuel system provide electronically controlled precision, enable class-leading levels of emission control, power, and fuel consumption. This is camera direct injection. That's all from us. Thank you.